We know that density of silver is 10.5, the density of rhodium is 12.4, and the density of platinum is 21.45. In this experiment, I'll be obtaining the density of 3 unknown metals in order to rename the bottles again. A laboratory balance will be needed, 150 ml graduated cylinder, and the first metal that we will be starting with is metal 1. So first things first, we need to find the mass of the graduated cylinder by itself. So let's do this. The mass of the graduated cylinder by itself is 73.1899 grams. Now we need to find the volume of metal 1. So we'll place it on the graduated cylinder and we will be realistically pouring. This is in no particular measure, we're just pouring at random. So now the measurement shown here is 14 ml. So now we're going to place the graduated cylinder on the laboratory balance. And now we need to subtract the mass of the graduated cylinder from its total amount. Earlier, we established that the mass of the graduated cylinder is 73.1899 grams. So now we need to subtract 73.1899 from the total mass, which is 221.9834 grams. And the answer that we get is 148.7935. This is the mass of metal 1. We know that the formula for density is mass over volume. So now we need to divide 14 ml, which was the volume of the metal, into its mass, which is 148.7935. This gives us 10.628 as its density. Now we need to move on to metal 2. The same process will be repeated. We select our scale once again, our 50 ml graduated cylinder, and our metal 2. We established that the mass of the graduated cylinder on its own is 73.1899 grams. So now we move straight into finding the volume of metal 2. Place this over the 50 ml graduated cylinder. And once again, we're going to be holding to pour. We have gotten 14.5 ml. Now we need to select the graduated cylinder with the metal inside and place it on our laboratory scale. And that gives us 254.4932 grams. Now what we need to do is subtract the mass of the graduated cylinder from the total amount. So that we have to subtract 73.1899 grams from this total mass. So let me do this. The mass of just metal 2 is equal to 181.3033. Now we know that density is equal to mass over volume. So now we need to divide 181.3033, which is the mass of the metal 2. And we need to divide its volume into it, which is 14.5 ml. The density will therefore be 12.503 or 12.504 density. So now, once again, we have to repeat the same process with the final metal, which is metal 3. Let me remove these and we add them. Adding the scale once again. Adding our 50 ml graduated cylinder. And adding our final metal, which is metal 3. Since we've already established the mass of just the graduated cylinder, we skip to the second step, which is adding the metal to the graduated cylinder to find out the volume. Holding to pour. We get 16 ml. So for the volume, we have 16 ml here. Now we have to place the graduated cylinder with its metal on the scale. And it gives us 415.8356 grams. Let me write this down. And we need to subtract the mass of just the graduated cylinder from this to get just the mass of the metal itself. So 415.8356 minus 73.1899. This gives us 342.6457 as the mass of only the metal 3. Once again, it will be 342.6457 as the mass of just the metal. Now, we know that density is equal to mass over volume, so we will have to divide the 16 ml, which is its volume, into its mass, which is 342.6457. So I will be doing that now. So the density of our last metal 3, is 21.415. The density of metal 3 is 21.415. For metal 1, which has a 10.628 density, will be silver, because silver is closest and it has a 10.5 density. For metal 2, which has a 12.504 density, we will be getting rhodium, because rhodium has 12.41 density, and that is the closest to it. For the final metal, which has a density of 21.415, we will be getting platinum, because platinum has 21.45 density, and this is the closest to it.